This is Project Anemoi video journal number 4. Now, when last I left off, it was 9 months ago. The reason why it's been so long is that I didn't work on it at all during school, mainly because the program that was communicating from the laptop to the Raspberry Pi was broken, because Microsoft likes to break things with their updates. So now that is programmed in all C++ with the correct drivers, like the official drivers that Microsoft tells you to use, and it's using C++ networking code and all that glorious stuff. That is actually running on my laptop right now. Over here we have the Raspberry Pi. We have the output of the program that's actually running on the Raspberry Pi, and this receives stuff from the internet and then pipes it over to the Arduino. This is the output from the Arduino. This is just the motor input, or motor outputs, if you could focus, yeah. This is just the motor outputs of all of the motors, and yeah, so now some other changes that I also made is that all of these components were, so the Raspberry Pi, the Arduino, and the little sensor stick were communicating with I2C. All of them would be able to communicate with each other, but that was causing a lot of problems when they all tried to communicate that way. So now the controls to the Arduino are actually sent over from the Raspberry Pi via SPI. So it sends over via SPI, it trips an interrupt, the interrupt just loads into a buffer really quick, and then it does that for every interrupt, and then it comes back around in the processing loop, and it picks up the stuff that was left in the buffer, and it clears it out, and it's working quite well. So, to see it in I guess I'll show you what it does now. So, actually right here, so before I arm it, I'm just going to show that, you know, I can control those. There's a lot of stuff. It prints out a lot of stuff, but you can see there's just like the vector here is the actual control vector. So that's the vector that we want the quadcopter to align with. It's basically almost straight up right now. This is XYZ. So XYZ is basically just pointing straight up, essentially, with a little bit of X and a little bit of Y. And then all this other stuff. So like, this is the control to disarm it. This is to arm it. This is what type of vector it is. That really does almost nothing. But so this is the magnitude of the throttle. So if I bring that up, you see, so those big numbers there, those are actually floating point numbers represented as a 32-bit integer, because that's how it's sent over. And this is actually using message pack as well. So these are actually the keys for the corresponding value. So basically what I do is I make a map of, so message pack actually does it a lot better, but it makes it less disgusting than what I'm doing. So the key is put in here, and then the value is put into here. But then when it comes on the other side, you have to say what you want the values to be interpreted as. I just say interpret all of these as 32-bit integers, and then it goes into another function and it makes it what it's actually supposed to be. It's not completely beautiful, but you know, it works. So I guess I'll just run it now. Here we go. So this is, so that it was arming it. Come on, guys. Okay. So as you can see, it is on an angle, and these guys are trying to make it level. That one is, and that one is. And if I bring this up, it should just slow down. Yeah, it should just stop, and I can bring it back down. Also, this is controlling on a global level, so basically, here, let me stop this. So I just have the disarm command and it stops. But so it's controlling on a global level. So when I go straight, I don't mean go this way. So the Raspberry Pi is on the front. Doesn't mean go this way. It means go north. North is like that way. So it is a global sort of control. I guess it would be called headless. But it always points to true north. And I can show that. I guess I have to fix that, but because I have to send some commands before it starts doing anything. So if I actually prop this up, I have my battery charger. Yeah, it's safe. Don't worry about it. Okay. So if I actually prop it up, this is straight. So this is actually trying to lean the quadcopter up that way and go that way. This one doesn't turn on when I go do that. Well, I guess it does. That's kind of proved my point. But it's not going very fast. See, there we go. And yeah, I guess try another test flight pretty soon. Currently the PID loop's not tuned, but I guess that's what test flights are for. So yeah. This was video journal number 4, and hope to see you soon in number 5. Thanks for watching.